Hello, hi everyone. Good afternoon. It's a pleasure to be here today. My session is about very exciting area using the blockchain technology to reinvent master data management. Why does this matter? Because master data is like a patient identities in healthcare or customer and product data in enterprise systems is the backbone of all the digital operations. If this foundation isn't secure and consistent and reliable, everything built on top of it becomes fragile. In my role at LabCorp, I have worked hands-on with these challenges, and I will show how we solve them by combining the blockchain with enterprise MDM. By the end, you will see how the distributed, immutable, and encrypted platforms can transform enterprise data management. What are the traditional MDM challenges? Data consistency issues with the traditional MDM and security vulnerabilities and performance bottlenecks and compliance complexity. Traditional MDM started simple, mostly as a database consolidation or a data consolidation, but modern enterprises operate across multiple geographies and multiple clouds and dozens of the applications. That creates four big pain points. First is data consistency. If the two systems update the customer record at the same time, you often get the conflicts or drift. Second is security. Centralized MDM is a huge target. One breach and the attacker controls all the master data. Then the third one is which is performance. As the data grows exponentially, system slows down. And the fourth one, final one is compliance. So compliance is regulated industries like healthcare and finance requires detailed audit trails and lineage. Most legacy systems bolt these features on or afterwards, which makes them fragile. These challenges show us why we need new foundation. Blockchain is for mainly four categories: immutability and consensus-driven updates and built-in cryptographic security and transparency. Blockchain directly addresses these four pain points. First one is immutability, means that once data is sorted, it can be tampered with. That is automatic audit trail. Second one is consensus, means that no single system decides. Multiple nodes must agree before the data changes, which removes the single points of the failure. The third one is built-in security through cryptography, ensures authenticity and confidentiality. And final one is transparency. Every participant can see and verify the state of the data. In short, blockchain's DNA is natural fit for the problems of MDM faces today. In traditional systems, this means keeping the logs and backups and complex access monitoring. But in the blockchain, immutability is built in. Once the transaction is written, it's mathematically locked into the chain. If anyone tries to change it, the system will reject it because the cryptographic hash no longer matches. This turns audit trails from the complex manual process into something automatic and tamper-proof. Consensus is about the agreement. In centralized system, the database administrator or single system can approve the changes. That's convenient but risky. Hacked. With the blockchain, multiple independent nodes must agree on the change. We use a practical Byzantine fault tolerance mechanism which can tolerate even one third of the nodes being compromised still remain reliable. This critical for resilience. It means the platform can withstand failures and cyber attacks or insider threats and skill deep data trustworthy. Every transaction is signed with a digital signature. Exactly who performed it. Data is encrypted both in the rest and in the transit. That's much stronger and simple than managing thousands of individual keys. In short, security is woven into the fabric of the system. Transparency is about the trust. In many industries, and disputes arise because each party maintains their own version of the truth. For example, in supply chains, one partner might claim an update was made, while another says that it wasn't. With the blockchain, everyone who has access to see sees the same verified ledger. That reduces the disputes, increases the collaboration, and builds confidence across teams and organizations. Transparency doesn't mean loss of privacy. Data is encrypted, but the fact that the transaction is happened is visible to authorized parties. Hyperledger Fabric is the one of the thing, and attribution-based encryption is the another one. IPFS is for large data storage, and OAuth2 JWT TLS 1.3 for the modern security. So we build our MDM platform on a carefully selected stack. At the core is a Hyperledger Fabric, a permissioned blockchain ideal for enterprise use. For fine-grained access, we use attribute-based encryption, which enforces the policies at the data level. For storage, large data objects go into IPFS and a peer-to-peer file system, and while the blockchain only keeps the cryptographic fingerprints of those files, keeping the ledger efficient. Finally, we secure everything with modern protocols. OAuth2 for authentication, JWT for session management, TLS 1.3 for encrypted communication. Together, these technologies give us both power and practicality. Our architecture is layered for the clarity and scalability. At the top, presentation layer exposes the REST and GraphQL APIs, so enterprises can integrate easily. The next one is application layer. It contains the business logic in the form of smart contracts, what Hyperledger calls chain code, and the consensus layer ensures the agreement using the PFBT, and the data layer combines the blockchain metadata, IPFS payloads, and Redis caches for fast retrieval, and at the base, infrastructure layer runs on the Kubernetes clusters across the availability zones for the failover and scaling. Each layer specialized, but together they form a resilient whole. We didn't jump straight into production. In the phase one, we built a proof of concept, which is basically CRUD operations, consensus testing, and performance benchmarking that validated the blockchain potential. In phase two, we piloted with the real workloads and developing smart contracts and optimizing throughput. We also deployed the attribute-based encryption. Finally, in the phase three was the production, building infrastructure as a code and setting up monitoring with different tools and designing disaster recovery procedures. And this strategy staged a journey, minimized the risks, and ensured the enterprise readiness. 99.9% 60%. The results are enterprise grade. Our platform processes over the 3000 transactions per second, delivers 99.9% uptime, and improves the data access by 60%. But the performance only the part of the story. Compliance is automated, and smart contracts enforce retention policies, and every change is logged immutably. In short, we didn't just match the traditional MDM, we exceeded in scale and reliability and trustworthiness. One is security implementation, how security implemented in defense in depth. AES 256 at rest and TLS 1.3 in transit. We protect the data at two levels: AES 256 encryption for storage and TLS 1.3 for all the communication. This ensures both the stored and the transmitted data are secure. And the second one is digital signatures. Every transaction is digitally signed, and so we know what exactly who performed it and can be prevent further repudiation. And zero knowledge proofs. And for highly sensitive operations, we use zero knowledge proofs. This lets someone to prove they are authorized without revealing the actual data. It's a security without overexposure. Instead of static roles, we use the attributes-based encryption. For example, only doctors with oncology specialization and active license can access the oncology data. Policies drive access, not the manual permissions. The second one is dynamic policy evaluation. Access is evaluated in real time. If someone's status is changed, their access changes instantly, no manual updates are needed. Immutable order audit trail. All access events are logged immutably on the blockchain, providing the regulator with the tamper-proof audit history. Third one is treat mitigation, DDoS protection. We use multi-level rear limiting and failover to observe the denial of the service attempts without downtime. Insider threat prevention. The second one is insider threat prevention. No single administrator can override the system because the blockchain requires distributed consensus. Even insider attacks are prevented. The third one is data leakage prevention. We integrated enterprise-grade DLP tools to stop the unauthorized data extraction, adding yet another layer of the safety. Data retention policies is the automated compliance framework. Within that data retention policies, the smart contracts automatically enforce the retention rules, no manual cleanups, no missed deadlines. Then the second one is comprehensive access logging. Even access is logged immutably on the blockchain, creating a reliable audit trail. And the third one is complete data lineage. We can trace the data across its entire life cycle: who created it, who modified it, where it is used. Supports the right to be forgotten with the cryptographic deletion. Then HIPAA compliance, enhanced protection for the sensitive health information. SOX compliance, built-in separation of the duties ensuring financial accountabilities. Government blue-green deployments. We run two identical production environments side by side. When the updates are needed, we switch the traffic from blue to green, ensuring the zero downtime. And then canary releases. New smart contracts are deployed first to the small subset of the nodes. If issues appears, we can roll back automatically before the problem spreads. Then future flags. Third one is future flags. We can turn the futures on or off selectively in production. This lets us test the real world behavior without putting the entire system at risk. Monitoring and observability. The CPU and memory and disk and network access for all nodes. And predictive analytics helps us spot problems before they cause the outages. And application metrics. The second one is application metrics. We measure the transaction throughput, latency, error rates, and business KPIs. Then the third one is blockchain specific metrics. We monitor the consensus participation and blockchain propagation times and chain growth rates to ensure the ledger itself is running smoothly. Incident response, how the incidents are tracked and how the incidents responses are captured. Automated detection, machine learning and anomaly detection, smart detection spot usually activity. Escalation procedures, we have clear escalation paths and automated notifications so the right people are alerted quickly. Support master process, postmortem process. Every incident is thoroughly analyzed and lessons are added to our run books and making the system smarter and stronger over the time. To conclude, the future data management is distributed, encrypted, and immutable. Blockchain based MDM is no longer a theory, it's running in production today, solving real challenges. It gives the enterprises a platform that is faster, more secure, more compliant than the legacy systems. At Labcorp, this journey has just begun, but the results already show the tremendous value. I hope today's session gave you very clear picture that why the blockchain MDM matters and how it can help your organizations build resilient, future-ready data platforms. Thank you.